Everybody, let's come back. Mm,
Hello. I
hello,
have
hello. Mm. Everybody, Vika, Егор, Катя, Коля. While we are waiting for everybody to come back, do you remember last week we studied chemistry? And do you remember what was the first topic that we have talked
like chemical and physical changes.
about? Good job, chemical and physical changes. And do you remember what is the difference between chemical and physical changes?
chemical change is a reversible change. No, hold on. A physical change is a reversible change. It either changes the state of the object, like
Mm-hmm.
water,
Yes.
like liquid, gas, solid,
Mm-hmm.
and yeah, it's reversible. Meanwhile, chemical changes are irreversible. When the signs of a chemical change is like
Don't, we will repeat it a little bit later. Don't tell the science. Yes, the irreversible changes when something new is created. So let's actually revise what is the science of a chemical reaction, and we are going to play bingo. So first of all, I want you to take a paper and a pen. And look carefully. I want you to draw 3x2 grid. It means it should be looking like this. 6 squares. Now, let's remember what signs of chemical reactions do we have? Karin, can you tell me one sign, any one sign of a chemical reaction you remember?
Bubbles.
Bubbles, good. Now you, one sign.
explosion.
Explosion, good. Kalt?
Yeah, fire or burning.
Fire, good. Igor?
Temperature changing.
Temperature change, good. Uh, Коля? Коля, do you remember any?
I forgot.
Okay. Vika, are you here? Do you remember any others? Could someone remember something else? What else can change?
Color.
Color. Mm-hmm. What else?
Smell.
Smell. Good, Karin. Good job. And we also have solid formation. Solid forming. So 7 signs. So I want you to choose any 6. And fill in the grid that you have. So the winner will be the person who crosses out the 6 squares for the first one, who crosses out all 6 first. So it's on your luck. Who guesses which one will be the first 6? Can you show me some reaction when you're ready?
Yes, I'm ready.
Good. Can you show me a reaction? Okay. Great, great. Okay. Let's take a look here. What sign of a chemical reaction is this?
Explosion.
Explosion, yes. So cross out explosion. Mhm. Let's look at the next one. What do we see
Color.
here? Color,
Color.
Kat, yes. Color change. Can you cross out color? Let's look at the next one. So we had 20 degrees, we added something. Now we
Temperature.
have 48. Temperature
Mm.
change, yes.
Is it
Mhm.
counting then you like 2 vertically?
No, it's only if you have all 6. We will see who will
Okay.
have all 6 first. Okay, what is this here?
Smell change.
Smell change, yes. Good. Next one.
Bubbles.
Bubbles. Yes, these are bubbles.
Okay, now I have 3 in a row.
Good. Let's look at the next one.
Fire.
Fire.
Fire, yes. Great. Are you
Mhm.
finished, Tanya? Igor, are you
I
finished?
need one more. I need
One more. Do we have anybody who crossed out all 6 already?
No.
No? Okay.
8.
Bingo.
Oh, I
Bingo.
have bingo. Yeah.
Yeah. What is this? It is, we have,
Solid.
we have 2 liquids. So we have a liquid and we have, sorry. And we have one more liquid added. And in here we see solid particles forming. Yes, this white
Then
stuff is solid. Yes, great, good job. Okay, last lesson we haven't finished talking about one more thing, about showing chemical equations. So when we talk about chemistry, in chemistry the chemical processes are shown using equations. So in these equations, we place things that react with each other on the left side. And then we draw an arrow and place products on the right side. Things that are reacting between each other are called reactants. And the resulting thing we get is called product. So we will be working with word equations. So we will be using words. And we need to determine which things are reacting. So what are the reactants, and place them on the left. And then draw an arrow which shows us that something is changing. We have a chemical process. And find out our product. Like, for example, let's look here. Anya, can you read the first sentence?
A reaction between sulfur and oxygen occurs to form sulfur dioxide.
Now, let's look at this sentence. What things are reacting in this case?
Sulfur and oxygen.
So sulfur and oxygen will be our reactants. Then we need to place an arrow and show our product. What did we get from this reaction?
Sulfur dioxide.
Sulfur dioxide. Good job. Now let's create the same for the second reaction. Karin, can you read the second sentence?
Table salts, sodium chloride, and water are products of a reaction between hydrochloric acid and sodium hydroxide.
Hydroxide? Yes, good job. So what are the reactants? What is reacting here? Let's look all together. Can you tell me what are the reactants here? Hydrochloric.
Yeah, acid and sodium hydroxide. Yeah.
Good job. And sodium hydroxide. These are our reactants. Great. So, and what are the products then? What is the result? What do we get in the end?
Table salt and water.
Table salt and water. Yes, Karin, good job. Table salt and water. Great. Yegor, can you read the next one?
A reaction with carbonate, such as copper carbonate, with an acid, such as
Hydrochloric. Mhm.
hydrochloric acid, results in a copper chloride, salt, water, and carbon dioxide gas.
Good. So let's look again all together. What is reacting here? What are our reactants? Let's look. A reaction with
Carbonate.
what? Which one? We have here the exact example.
Copper carbonate.
Copper carbonate. Good. With what? What does it react with?
With acid.
With acid, with hydrochloric acid, yeah? Carbonate, I will write here just plus acid, but should be hydrochloric. And what do we get in the result? Here, Yegor. What are our products?
Copper chloride salt.
Okay. Is it?
Water and carbon dioxide gas.
Water and carbon dioxide. Good. Good job. Vic, can you read the last sentence?
Carbonic acid decomposes easily to produce carbon dioxide gas and water.
Good job. What is reactant here? What do we have in the beginning of the process?
Carbonic acid.
Good job. Yes, we have carbonic acid. It does not react with anything. Yeah, we have here just decomposes to create what? What are our products?
Carbon dioxide.
Good job. Carbon dioxide. Is it all?
Gas and water.
And water. Good job. I want you to try to do this on your own for a little bit different one. Can you please go through the link in the chat and complete the word equations with the words shown? Mhm. Vika, Katya, how are you doing? Vika, good. Katya?
Yeah, I'm doing it.
Mixed up the order and it showed yes incorrect, don't worry. Yes. Mhm. Good. So, good job. But today we have a new topic. Today we are going to talk about states of matter. Do you remember what is matter?
It's like why
Yes.
things happening.
Thing.
No. Anya?
What thing is made out of?
What things are made out of? Everything that has mass and volume is called matter. Everything else is called energy. And matter, we have 3 states of it. Yeah, because what happens? Matter is made of particles, of small things. Yes, and these particles can be arranged in different ways. It can be very packed, then can be packed a little bit more loosely, or can be like very loose. So matter can be found in 3 main states. What are these states?
Solid, liquid, gas.
Solid, liquid, gas. Yes. I want first to check what you already know about solid, liquid, and gas. And I want you, again, to go through the link in the chat and try to sort the things given into appropriate columns about solid, liquid, and gas.
Okay, finished.
You're very fast. Yeah. Wait for everybody.
I made a mistake right at the end that I didn't want to do, so I started over.
Oh my God.
And now I did it at like 20 seconds.
Good. Okay, okay. I'm prepared. Karin, are you here?
Yeah, I'm here.
How are you doing?
I'm finishing.
Okay. Let's wait for Karin to finish and we will discuss. Let's take a look at this now and discuss together. So, which one of these? So let's look at the first one. Particles are close together but random. So they're still close, but moving randomly. Which one is it? Solid, liquid, or gas? What do you think?
Liquid.
It is liquid when particles are close, but they are not bonded, so they still move around. Good. But when do they are packed together and vibrate but no don't move? Which one?
It's solid.
It is
Solid.
solid, Igor. Good. Which state has the fixed shape and fixed volume, so it does not change the shape and volume?
It's solid.
Solid again. Good. And what picture is this for?
Solid.
Or
Solid.
great. Which material cannot keep its shape and also fills all the space that is given to it?
Gas.
Gas.
Gas, yes. Particles spread out and can move quickly. Karin,
Yes.
Gas.
gas, yes. Which picture is this for, Vic?
I think this is
Gas.
Vika?
Gas.
gas.
Vika, what? Gas, yes, okay.
Mhm.
Quite, what is this picture
Liquid.
for? Liquid. And we're left with the last statement. It is also about liquids. That materials take the shape of the container,
Liquid.
but stays the same volume. Good. Now, let's play true or false. So I'm going to show you a statement. If you think the statement is true, I want you to show me some green reaction. Can you show me green reaction? Cool. Great. If you think the statement is false, I want to see a red reaction. Can show me any red reaction. Great. So these will be about solids. So these are about solid state. Igor, can you read the statement?
Particles are close together.
So, can you show me what do you think? Is it true or is it false? Anya. It is true. Good job. Particles are close together in solids. Kat, can you read the next statement?
There are no bonds in solids.
So,
Oh, sorry.
what do you think?
Wait, what is bonds?
Bonds are connections between particles. So these lines are called bonds.
Okay. Well, I think it's true because there is no connections between all. Like, they are just
Okay.
close together, I think.
Let's see. Kari thinks it's true. Igor thinks it's false. Anya thinks false. Karina, true. Okay. Let's check. This one is actually false. There are bonds in the solid. So actually, the particles are fixed together and they don't move around because they have these bonds that hold them in place. So solids do have bonds. Good. Cole, can you read the next one?
Particles vibrate in a fixed position.
Particles vibrate, yes. So what do you think? Igor? Let's choose something. Okay.
Alright. I think it's, I don't know, it's be false.
This one is actually true.
Okay.
So in the solids, particles are connected with the bonds, but as usual particles always want to move. They always want to go somewhere. But because in solids, they have bonds, they are bonded together, they don't move, and they just stay and vibrate in the fixed position. Because they want to go around, but they cannot. So they're fixed and they vibrate. Mm-hmm. Karin, can you read the statement?
Solids can be compressed.
Compressed. We can change the volume. Is it true? Or is it false? Anya, Vika, Oля, Igor. This one is actually false. We cannot change the volume of solids. Solids have fixed volume. So let's look. Particles in a solid state are packed closely together and held together by bonds. So that's why they don't move around and they vibrate in a fixed position. They also have a fixed shape, don't flow, and we cannot compress it. Compress means in this case, change its volume. It will have the fixed volume. Let's talk a little bit about liquids. Liquids are still have particles close together, but in this case, they are arranged in random order, and they don't have bonds now, so they move around each other. So this is why they want to move around each other. And liquids can flow, but they cannot be compressed as well. We cannot change their volume, but we can change their shape. They take the shape of the container. Let's fill in, choose the correct words for the gas state. Vic, can you read the first statement and choose the correct collocation?
Particles of gas state are close together far apart.
So in the gas state, are they close together or far apart?
Far apart.
Far apart, yes. Good job. They are far apart. And Anne, can you read the next one?
Okay, arranged in random order.
Random order, good job. So particles in gas state, they are far apart and random, and they move quickly in all directions around the space that is given to them. And gases can flow, we can change their shape, and we can change their volume. They take the space that is given to them. They fill in the whole space that is given. Let's look here. Igor, can you read the first statement?
As fixed shape cannot be compressed.
Can you tell me what state is this?
Wait,
Solid.
wanted. Wait.
Solid.
Oля, it's Igor.
No, I
Answer.
don't know what words it's called. Like, I
Okay,
forgot.
Kol, can you help us? No,
Me?
Kolya, can you help us now?
Solid.
Yes. Solid, can you write it?
Me?
Yes.
Yeah.
in the space that is given. Solid. Can you draw the shape? How does it look? Mm-hmm. Good. Karin, can you read the next one?
Takes the shape of its container and fill it in completely.
What do you think? What state is this?
Yes.
Yes, yes. Can you draw the particles and write down the state name?
Yeah. Okay.
Mm-hmm. Vika, can you read this one?
Atoms are packed closely but randomly arranged.
What do you think? What is this about?
Maybe gas?
Mm.
No.
Yegor, do you agree? Is it gas?
Mm,
Karina, good job.
wait.
When they're close together but random, what state is this?
It's not gas, it's liquid.
Liquid, yes.
Liquid,
Igor, can
yeah.
you write down the state and draw the particles? Here. Igor?
Me, yeah.
Yeah. Can you please?
Li- How it's spelled?
Vika, do you know how to write liquid?
I know
Yes.
how I can
Can
draw
you
it.
help us to write liquid?
Can
Mhm.
Wait.
Liquid.
not here.
Good job, Vic. Thank you. Igor, can you draw the particles? Yeah.
Okay. So let's do this, there, this, there, this.
Good job. Good. Katya, can you read the last statement?
Atoms can move freely and very fast. So I think it is also gas.
Good job. Can you draw the particles and write down the
Okay.
state? Mhm.
Yep.
Good job. Yes, amazing. Thank you. So now let's talk a little bit about how do these states change. So we can go from solid into liquid into gas if we raise or lower the temperature. Yeah. So when we oh my god, everything is so full, sorry. Give me 1 second. So this thing is wrong. So when we heat up solid, it turns into liquid. How do we call this process of solid turning into liquid? Do you remember? What is the name?
Heating.
Melting.
Melting.
Melting. Yes,
Melting, yeah.
melting. Good. What is then we can heat it with a liquid and it will turn into gas. What is the name for the process of liquid turning
Evaporation.
into gas? Evaporation. Good. Or
I have no idea.
there is another option that they can call it. Koda, do you remember?
Which? From gas
The
to
liquid
solid?
into gas. No, liquid into gas.
Evaporation.
Or there is one more
Heating,
option.
maybe.
Mm-mm. It is called boiling.
Yeah.
Boiling.
Oh,
You have two options here, so melting and boiling. So when
Um,
we
Condensation.
condensation, yes,
And freezing.
good job. And freezing. Great. So there is this two words, boiling and evaporation. Let's quickly discuss what's the difference between these two. Let's imagine we have 2 cups with water. Here will be boiling, and here will be evaporation. There is actually a difference between these two. So boiling is happening at boiling point. So it will happen at a certain temperature. What is the boiling point of water? Do you know?
Yes.
100%.
100,
Persons.
not percent,
Ой, градусов.
degrees.
Degrees.
Good. So water starts boiling, for example, at 100 degrees. So boiling is a process that happens when water reaches 100 degrees. So we need to heat it up to this temperature. And when we heat it up, it happens in all of the volume, all over. That's why we see bubbles on top, because gas from the inside goes to the outside. That's what is called boiling. All inside the volume. And happens at a certain temperature. And it is very fast. Evaporation is a process that happens all the time. Like right now, in my glass, water is evaporating. It happens at all of the temperatures. Have you ever had the situation when you like leave a cup of water and then go to your country house for holidays?
Yeah,
And it's evaporate.
Yeah.
What did you see when you come back?
Evaporate.
there was a little water.
Like what? There were a little water, or maybe the cup was dried out. Yeah.
Yeah,
It happens because water is evaporating at all temperatures. But this is a very, very slow process. Very slow.
Temperature
And-
more higher, it's became faster.
Yeah, if we put the temperature, if we warm it up, it will be faster. Yeah. But it happens only on top of the liquid. So the top particles fly away. So that's why it's slow, because it happens only on the top. Only on top. And molecules, because molecules, remember, they don't have bonds and they always move around. So sometimes they just fly away. So that's what happens during evaporation. Now, let's look here. So melting point of water is 0. Boiling point of water we've already said is 100 degrees. Can you tell me what is the state of water at 83 degrees?
Liquid.
It is liquid. Yes, it's between 0 and 100, so it's still be liquid. Good call. What about at minus 60?
Solid.
solid.
Solid, Karin. Yes, good job. It is smaller than 0, so it is still solid. Good. What about at minus 8,
Liquid
Igor?
was solid.
Solid.
Solid. It is solid at minus 8. Good. What about 110?
Boiling.
Katya again?
Boiling.
What is the state of water?
It's liquid.
Is it? Do you agree, Karin? What do you think?
Wait. Well, it's boiling point and it's evaporating. So it's like, but it
Its
can
boiling point is at 100 degrees. At 110, what is the state?
Okay, so gas.
Gas. It's already gas at this point. Good. Good job. Now let's look here. We have iron with the given melting and boiling points. What will be the state of iron at 2400 degrees? Anya?
At 100, at what? At 100
Liquid.
degrees?
2400 degrees.
It will still be liquid.
Liquid, yes, good job. Vic, what about aluminum at 1200 degrees?
It is liquid.
Liquid, yes, good. Karin, what about tungsten at 3000?
It's liquid.
Let's look carefully.
It's solid.
Solid, yes, good. Colin, what about mercury at 1000 degrees?
Gas.
Gas, yes, good job. Okay, let's pause here for today. And next time we will continue discussing states of matter and we will talk also about a new topic. But for now, let's pause here. Thank you so much for today. This is all I have for you. And let's go relax. Thank you.
Thank you,
Bye.
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 Bye bye.
Bye.